Welcome to Simplifying Roots. In this video, I'll go over how to simplify basic roots like these. So first, this is a root or a square root, and this is basically just equal to what is a number or x squared. So I can write a 2 here just to remind myself that I'm trying to find what is x squared. So we know that 64 is just 8 times 8, or it can be written out as 8 squared. The square root of 64 is equal to 8. Here we have 49, and it's the same principle. Square root is equal to x squared. So we know that 7 times 7, or 7 squared, is equal to 49. Therefore, the square root of 49 is equal to 7. Okay, so now that we've gone over the fundamental principles of square roots, I want to go over cubed roots. So cubed roots are just equal to x to the third. To the third is just multiplying a number 3 times. So we know that 3 times 3 times 3 is equal to 27, or you could write it out as 3 to the third. So the square root of 27 is equal to 3. Okay, so now we have a quartic root, and we don't really need to call it a quartic. We just remember that this is an index. This is what this number is called, and we're just putting that to the fourth, whatever number to the fourth, or a number multiplied 4 times. Now, don't get this confused with a square root, because 16 is also a square root of 4. But we're not doing that because we have the index of 4. So the quartic root of 16 is 2 times 2 times 2 times 2. Also could be written as 2 to the fourth. So we know that the quartic root of 16 is equal to 2. So now we've gone to square roots that do not have a perfect square. So this number right here is not a perfect square, and we know this because 8 squared is equal to 64, and 9 squared is equal to 81. There's no number that can be squared to equal 72. So when we would do this number, we would get a decimal. But we're not actually trying to solve it. We're trying to simplify it. And basically what that means is we're trying to get whatever number in here to the smallest number it could possibly be, and then have a number out here multiply to that. Okay, first of all, to do this, we need to identify this root. So this is a square root, and I can write it to just remember that we're trying to do x to the squared. And now there's a set of numbers that we need to remember. 2, 3, 5, 7, and 11. And these numbers are important because they can't be breaking down any further. They can't be divided any further than it can be, and that will help us try and get the smallest number in here. Okay, so now that we've got our primary numbers, the numbers that can't be divided any further, and we know that's the square root, we can start solving, or simplifying I mean, for 72. So first I'll start off with 2, and what I mean by this is we're going to divide this number by 2 until we can't divide it by 2 anymore. So 72 divided by 2 is 36. And then we're going to keep going. 36 divided by 2 is 18. And 18 divided by 2 is 9. But now, we can't do 2 anymore because 9 is not divisible by 2. So we'll move on to our next number, 3. And we know that 3 times 3 is 9. Okay, so now that we've written out our factor tree, we're going to look at our index of 2 right here. And this basically means that we're looking for groups of 2. So we're just looking for pairs. And I see a pair right here, groups of 2 right here, and a group of 3 right here. And I'm just going to write out 2, and then 3. And then we have this lone 2 right here. So now I'm going to write out our square root. And we can see that we have the group of 2, so we can take a 2 out, and we have the group of 3, and we can multiply that by 3. And now on the inside, we're just going to put our lone 2 back in here. So we've taken out 2 and 3, which were pairs because it was a square root. And 2 times 3 is 6. And then we'll put it back here, 2. And this is how you simplify a radical. Okay, so now we have an even larger number, 448, and it's to the cubed root. And this, remember, is just x to the third. Now we're just going to do the same thing and write our prime numbers 2, 3, 5, 7, and 11. And do our factor tree again. 448, we'll start with 2. 448 divided by 2 is 224. Keep going. 224 divided by 2 is 112. Divided by 2 again is 56. Divided by 2 again is 28. Divided by 2 again is 14. And divided by 2 again is 7. Now I know we can end here because 7 is prime and it can't be divided any further down. So now it's to the cubed root, and this basically means we're looking for groups of 3. And this would apply to the same thing if it was index 4. We'd be looking for groups of 4, and the same thing if it was 5. We'd be just looking for groups of 5. But since it's a cubed root, we're looking for groups of 3. So I see a group of 3 right here, another group of 3, and then a lone 7. And we'll just write out the groups of 2 that we took out, so just 2, 2. And now make sure when you're writing it, you remember to put the 3 because this will matter a lot, I assure you that. And we'll just take out the 2's that we took out, so 2, and then another 2, 2. And now we have that lone 7 again, and we'll just put it in, and we know that this can't be divided any further. And we'll just multiply these two. 2 times 2 is 4. Remember the index 3, and then 7. And this is how you simplify that root, or this radical.